Hello, my name is Heimrih and my final year project topic is about simulated annealing approach for optimal batching in a multi-level warehouse. Warehouse is typically required in a large-scale supply chain. A warehouse reorganizes and repackages products to be distributed. In a warehouse operation, the order picking process, which means that an item is picked or retrieved from the warehouse to be shipped out. According to Photo, this order picking process usually accounts for 50% to 70% of total warehouse operating costs. As you can see here in this figure described by Bertoldi and Heckman, traveling takes up the most time during order picking, making it the most significant process and contributes a lot in warehouse operation costs, making it very expensive. So, the most logical way to solve this problem is to reduce the traveling time. But how can traveling time be reduced? This is where the order batching comes into picture. Order batching is the grouping of customer orders for the picking process. When the orders are batched, the pickers are able to pick up items from multiple orders in one trip. By picking up several orders in a single batch, they can save time without going back to the same area to retrieve it again. The order batching problem, or OBP, aims to optimize the order to batch assignments so that it is able to reduce traveling path and time. Finding the shortest path to retrieve the items is known as the non-deterministic polynomial time problem, or known as NP-hard. NP-hard problems are often solved by using heuristic approaches. One common heuristic approach is simulated annealing. Hence, we propose that using the simulated annealing algorithm, we would like to optimize the order batching so that it is more efficient in batching assignments to further reduce traveling path and time. We want to determine whether the simulated annealing algorithm performs better at minimizing the total travel distance within a warehouse by optimizing batching orders when compared to other approaches. Performance of simulated annealing under different sample sizes are not widely investigated. The objectives of this research are 1. Optimize order batching in order to contribute to minimize total travel distance in a warehouse by using simulated annealing algorithm. 2. Find the efficiency of SA algorithm when performing the batching solution by using different sample sizes. 3. Evaluating the performance of simulated annealing algorithm to batch orders compared to other existing batching methods in producing batching solution. The scope of this research is that the items placed on the shelf are known and are unique. The orders are known in advance where a list will be generated. This research work only considers a single picker scenario. The pathing in the warehouse is using the optimal nearest distance pathing. Simulated annealing. Simulated annealing algorithm is based off a real-life process called annealing. It is when you take a molten hot metal and you cool it down slowly so that it is able to achieve a more stable form. The way we implement this algorithm is first, we define our initial parameters. The initial parameters, Tmax, is set at 10,000 with a stopping temperature Tmin of 1. The cooling constant C is set at 1. From the start, we set the initial temperature T. Then, we generate the initial solution. The total distance of the initial solution is calculated. A new solution is generated by making a change to the current solution by randomly swapping the orders. The total distance from the new solution is calculated. After that, the change of distance, delta E, is calculated. If the delta E is positive, accept the current solution, which means that the new solution is better and it becomes the current solution. If it is negative, the acceptance function P is calculated. Then, a random number R between 0 to 1 is larger than the acceptance function is considered. If it is larger, the new solution is also accepted. Otherwise, the solution is not accepted. The current temperature will be updated with the cooling constant C. This repeats until the current temperature reaches the stopping temperature, which means that it is essentially 10,000 iterations to run this algorithm. The simulation will be written in Python. We first transform this warehouse into a warehouse matrix. The X indicates the pathway, while the numbers indicate the item code. Then, a list of items are randomly generated to become the pick list. This research work aims to focus on two other batching methods other than simulated annealing method. First, the first come first serve batching method, or FCFS, and next the sort batching method. First come first serve is that the items are batched according to the list received, where whatever is in front will be batched first. For the sort batching method, sorting the list in an ascending order, it is expected to reduce the distance by a lot. This is because by sorting a list in an ascending order, the list could consolidate all similar items in the list together and the items from in proximity together. Simulated annealing is able to contribute to minimizing the total distance in a warehouse. Comparing the unbatched and batched solutions, as we can see here from this figure, it is clear that there are some reductions in the total travel distance. Simulated annealing algorithm is able to contribute to further optimize the order batching sequence as compared to the batch FCFS method, and simulated annealing algorithm is able to further improve the solution by 64.27%, which is a reduction of 698 meters. Furthermore, comparing the sorting method with simulated annealing is able to reduce 71 meters in distance, which is a 15.46% decrease in the distance. This result has proven that simulated annealing is able to optimize the order batching. Next, another study is done by comparing the performances of different batching methods. Simulated annealing algorithm finds the most reduction in distance travel across all sample sizes tested. If we look at the list of 20, there is about 141 meter reduced, and that is about 57.31% improvement compared to the unbatched list. For the first come first serve method, a reduction of 111 meter, that is a 51.39% decrease, and for the sort batch method, it is about 41 meter reduction, that brings about 26.58% of improvement in the total distance. It's also clear to see from this figure that simulated annealing algorithm performs better when batching orders. And when we compare to the other existing batching methods, it is better in providing the batching solution. We can also see that the reduction is more significant as the list size increases. The same trend was shown in other batching methods too. And finally, the percentage difference between batch FCFS method and simulated annealing batching method is about 50% to 60% for all sample sizes. It is consistent as the list of items for 20, 50, 100, 500 and 1000 are distinct. Even at different sample sizes, simulated annealing algorithm produces a constant improvement to the batching solution, which is decreasing the total distance traveled. In conclusion, this research work proposes the simulated annealing algorithm for optimal batching in a multi-level warehouse. The objectives of this research work are achieved. This research work successfully found an optimized batching solution based on the simulated annealing algorithm for distance travel with the same randomly predefined order list in a warehouse. This research work also found that the simulated annealing method performs better than other existing batching methods such as the sort batching and the first come first serve. Simulated annealing algorithm also shown to be doing well across different sample sizes from small sample size to a large sample size when comparing to the batch FCFS method. In the age of the fourth industrial revolution, e-commerce has been blooming and smart warehouses are becoming more popular. Further application of simulated annealing algorithm may be used in drone or unmanned robot picking in a smart warehouse where the robot can follow an optimized pick list based on simulated annealing algorithm. And that is all for my presentation. If you have any question, feel free to leave it in the comments below. Thank you.